Hello, Divya ma'am.
Good morning, ma'am. Am I audible?
Yes, one minute. I'm addressing Rajashree ma'am. In between, the network problem was there. So let me give 2 minutes. Rajashree PM did her BTech in Biomedical Engineering from University of Calicut, Kerala during 2007, MTech in Biomedical Engineering from Amrita Vishwavidyapeetham in 2009, and she is pursuing PhD in Biomedical Image Processing from VTU. Her research interests include medical image processing, virtual instrumentation, and biomedical instrumentation. And she has published more than 25 research articles. And her recently, one of the paper accepted in IEEE MBS 2022 conference at Glasgow, Scotland. And I'm one of the co-author in that. We are very happy to invite you, madam. And she is currently working as a faculty in electronics and instrumentation at RVCE Bangalore. Welcome you, ma'am. So over to you.
Thank you, ma'am, for the introduction. And first of all, we wanted to thank, on behalf of RVCE, to Dr. Usha ma'am and SR University and to all the coordinators for giving us a wonderful opportunity. So I'll be just sharing my screen now. Is the screen visible, ma'am?
Yes, ma'am, it's visible.
Visible. Okay. So good afternoon, all of you. So welcome all of you for today's session, this particular session on medical image processing. So basically we'll be discussing about what are the different challenges and opportunities of deep learning, basically convolution neural networks in the field of medical image processing. So this session are handled by both myself, Rajashree, and Dr.VEENA Divya. So coming to the agenda of this presentation, so we'll be giving a brief introduction about or overview about medical imaging, and we'll be discussing some of the brain abnormalities and what are the different image modalities normally used to detect this kind of brain abnormalities. And then a brief introduction about convolutional neural network, because mostly all the sessions we have already understood what is a deep learning network and convolutional neural network. So we'll be giving a brief overview about that. And what are the studies basically happening, going through, and what is the current market about this on this studies of deep learning systems, and what are the different data sets and image formats normally we'll be using for these kind of research studies. Whoever is pursuing research in this particular area of medical imaging, and what are the different challenges and opportunities. And then after discussing many challenges, we'll be narrowing down into a particular challenge on image or annotation basically. And we'll be discussing about two different tools which is used for image annotation. That will be Supervisedly and D7 Darwin. And some of the applications like case studies also will be presenting. So I hope my slides are changing and I'm audible. Any response? So I hope all of you can see my screen. So just starting with an introduction of medical imaging. So this is a general definition of medical imaging, where this is a technique and process of imaging the interior of a body for clinical analysis and medical intervention, as well as visual representation of the function of some organs or tissues. So basically in medical imaging, we'll be able to reveal the internal structures which is hidden by the skin and bones, as well as which will be helping to us to diagnose and treat some kind of diseases. So medical imaging also establishes a database of normal anatomy and physiology to make it possible to identify abnormalities. So in this particular slide, you can see an MRI scan, the images basically, and equipment, MRI machine, where how the imaging it is being done. So this is just for an example. We have just taken this image. And coming to the different type of brain abnormalities, there which includes strokes, so which is generally called as brain attacks also, basically which can be occur when something blocks the blood supply to part of the brain. Okay, so or when a blood vessel in the brain bursts. So this can cause a stroke, a condition, or another abnormality. What can happen in particularly in brain is a brain tumor. So basically, brain tumor is a mass or a growth of abnormal cells in our brain. So many different type of brain tumors exist. So some can be cancerous, so which is called as malignant, or it can be non-cancerous or benign. And other abnormality can be multiple sclerosis, the short form is MS, which is kind of an immune system attack, uh, which which basically attacks the protective sheet of myelin sheet basically, and which covers the nerve fibers, and which can cause some communication problem between your brain and the rest of the body. And one more very commonly seen abnormalities are as like a migraine. It's a very common thing. It's basically a headache, which is with varying intensity and which is often accompanied by nausea. And there can be some infections or lupus. Lupus is a kind of autoimmune disease which occurs when our body's immune system attacks our tissues and organs. So these can be, these are some of the examples of multiple brain abnormalities that can occur. So to find out what is the exact reason, or because of what reason we are getting a particular a symptom of this thing, we should go for, according to the disease and the symptoms, we'll go for different modalities to understand the structure. So in that case, a different imaging modalities, what normally is used in brain imaging are MRI, which stands for magnetic resonance imaging, and CT, computerized tomography, fMRI, most of you will be familiar with this, functional magnetic resonance imaging. And to understand the nerval or the electrical activity of the brain signals, we'll be using either EEG or MEG analysis. So electroencephalography or magnetoencephalography can be taken. And one more is a near infrared spectroscopy, which basically monitors the brain's oxygen saturation. So in all these different imaging modalities, basically the computer tomography, that is CT scan, which basically uses X-ray images and a series of X-ray images, which basically converted into a cross-sectional images of the brain. But it is because it uses X-rays, which is a bit harmful for our body. So most of the imaging modalities will be going for MRI imaging. So in magnetic resonance imaging, basically use of a strong magnetic field and a very high frequency radio waves are used for to produce detailed images. And MRI, because it does not use X-rays, it's comparatively safe. So because of all these reasons, and in positron emissions also, we'll be injecting some radioactive material and we'll be analyzing the brain activity or structure. So in functional MRI, basically can detect changes in blood flow and oxygen levels that results from your brain's activity. So according to the condition, so what symptoms you're going to a doctor, Basically, doctor can suggest you to undergo some of this imaging or this kind of modalities, so that we'll come to know what is the exact condition what you are going through. So as I told, because MRI uses radio waves and CT uses X-rays, and there are some adverse effects when we use harmful X-rays. So maybe later on it can cause some kind of like after effects because of the radiations. Because of these reasons, in most of the studies in literatures, if we refer, we can find MRI images or MRI scanning imaging methods are most commonly used for brain imaging. And there can be some benefits when we use this kind of medical imaging with radiation. Maybe it gives a better view of the organs, blood vessels, tissues, and bones. And it gives or provides a detailed information to help to decide whether a surgery or what kind of treatment should be done later on. So these are some of the imaging modalities normally is used. And so now coming to the introduction or overview of CMM. So I hope that this picture or the figure, this most of you are like very familiar nowadays, because in classical ML or machine learning, so whatever it is the image or data, whatever is the input, so this is the particular way of the way at which the analysis which will happen. So the input will be given to a feature extraction model or a block, where the important features will be taken over or identified, and based upon the feature extracted, we'll be doing or training a classification model, and the model will be able to predict the output. So this basically happens in a classical ML. I hope the screen, the slide is visible to you, the block diagram and the introduction to CML. So whereas in a deep learning approach model, we are basically combining this feature extraction. There is no exactly a feature extraction block as such. We have previously people used to tell kind of a black box, what we don't know what's happening. We are just giving an input and we're getting an output there. So basically we need to train it as having multiple number of layers, so which basically can understand what are the different features, and according to the data, whatever it understood, the feature is extracted. It will be learning or the training the model, and it will be able to help or to take into a decision. So the various deep learning methods use data to train neural network algorithm to do basically a various of or variety of machine learning tasks. So basically in this task, there can be classification, object detection, or segmentation. So there can be three different applications normally is used in imaging. So convolutional neural network. So basically these are all part of deep learning algorithms, which are very powerful for the analysis of images. So in image processing, when we see the applications of convolutional neural network, it is basically used for identifying a tumor. So most commonly, most of the papers or research, what is happening in the field is of a brain tumor detection. So using MRI images, you can find many number of papers in this particular area. So there normally the research are classified into two categories. There in one set of paper or algorithm development, they'll be focusing only on the segmentation of the a particular tumor. So what is the area or the size of the tumor, all that analysis will be done. And the other set of algorithms, there will be concentrating on classification algorithm in detail, where to identify whether a brain tumor is abnormal or normal, or in other words, in medical terms, whether it's benign or malignant. So this is basically done. So deep learning has various applications like image processing, natural language processing. But in today's our presentation, we are mostly concentrating on image processing. So it has wide variety of applications, and you would have known what are the different layers which is involved in a deep learning or convolution neural network. And coming to to a detailed market survey, when we did a survey, when we searched some papers from the literature, we got an understanding that. So you can see the graph on this slide. So this basically shows in a study of 2020, which basically did an image recognition segment, basically. So it is, as I told, in deep learning, we can use for image recognition or segmentation or classification in that way. We found out that so the different bars are like, one is for signal recognition, one is for image. The second bar is for the image recognition and data mining, and for the other application. So in 2020, you can see how is the graph, and it is predicted that by 2028, you can see how well deep learning networks or this market, what is the hike or what is the improvement which is going to happen. So there are a lot of studies and research which is happening in this particular area, and many researchers are working on this particular area of deep learning, and which is application in image recognition. So deep learning software, so basically this kind of network or software or tool, which basically helps the radiologists to deal with a large workload of interpreting different medical images. So basically for any other organ or imaging, normally we'll be using ultrasound scans also. But in case of brain imaging, we won't be going for ultrasound scans. So normally this kind of tools, why researchers are more interested in kind of deep learning or developing this kind of algorithm is like to reduce the workload of the radiologist, who will be from a day long this thing, they'll be analyzing different radiographs, all that. So this is kind of a algorithm or a tool which will help them to make the interpretation very faster. To help in the interpretation, these kind of softwares or tools can be helpful. So and there is one kind of a chat bot. So deep learning in healthcare is used in chatbot. So that's kind of a chatbot in medical imaging solutions, which basically can identify the patterns in patients' symptoms. So where if a patient, if he tells about some of the symptoms, these are my symptoms, this kind of machine, a deep learning model or a chat box can give some prediction or can identify, okay, maybe this symptoms is for a particular disease or something. So that kind of to identify a particular health issues in an early basis. So the early detection is a very important a crucial step in any medical imaging. So as early as possible, if you find out any abnormalities, the treatment and the further processes will be very helpful, and we can actually treat it properly. So the early detection, to do early detection, so many algorithms or this kind of deep learning methods are developing or developed. So now coming on to as we discussed about what are the different, what is a medical imaging, what are the different brain abnormalities, and what are the different imaging modalities normally used. Now, from where we'll get these kind of data? That is a very important challenge. So basically, this session is all about challenges and opportunities. So even though many researchers are working in the field of deep learning and machine learning or artificial intelligence, whoever is working in the medical area, the main important challenge many people are facing is about the data set and the image format. So normally for any MRI images or MRI scan, when we will do, it will be available in a format called as DICOM. Okay, so DICOM basically stands for Digital Imaging and Communications in Medicine. It's basically a standard which uses in the management of medical imaging information and related data. So normally in any other images, see the images images can be saved or stored in any other formats like JPG, PNG, or TIFF formats. But DICOM is the standard format that basically used in medical images. With the earlier days, actually, there was a problem because in all the hospitals and clinics, they'll have a DICOM reader with which they'll be getting with the procurement of the particular device or something like MRI machines and CT machines. So readers will be available, so a licensed reader, so that they can read and get all the informations properly. But sorry, sorry, ma'am, am I audible? Okay. The main problem what researchers are dealing with is on the image formats and the data sets. So in image formats, maybe before 2020, before the development of many deep learning networks and machine learning networks, it was very difficult task to get the like kind of a readers, like DICOM readers, and there was very less number of tools that was able to process this kind of images. So that was one of the challenges most of the people or researchers they were facing initially, because if a DICOM proper reader is not available, then they have to convert the image into a particular a JPEG or a PNG or a TIFF format. But basically, when you convert this kind of image formats, there can be a possibility of a loss of data. So the essential or the very valuable data can be lost. So then you can understand if the input is having a less number of valuable data, means how will be the training of the model and the prediction. So that's a very, very important or a basic challenge that researchers are facing. But with the help of the deep learning and machine learning or artificial neural networks, all these the development. Now, in most of the tools, they have a particular DICOM reader or commands. If you, for example, in MATLAB or Python, they have like commands or toolboxes which can be used for reading and which can able to process a DICOM images as well. So, and about the data sets, why people are more going on to a particular, maybe an MRI or this kind of images is like about because of the use of or the availability of publicly available data sets. So this is one example we've given on the slide. So basically, this is a brain tumor data set which is available in Figshare. There are different data sets basically contains MRI or brain MRI images. One more example is can be an OASIS database, which stands for an open access series of imaging studies. Now in OASIS database, we can find MR images and PET images, which is publicly available, through which researchers can work, download the data set and work on it. And another important problem or the problem normally what people will face when you use a publicly available or different data sets which is available on internet is if you download data sets from multiple sources, so that can cause some problem. When you create a model with images with multiple type of images which is taken from different sources, the equipment or the source which is able or which is used to capture these images, that the features or the radiation, the amount of radiation, all these can be different. So there can be some problems when we use multiple type of images from internet in this aspect. So if possible, we can create a robust data sets from the start if possible. And there can be the existing data sets which is available, which can have a data set bias in the sense only some type of, even though there are different type of abnormalities and different type of images, their database will have, or the data set will have, a particular kind of data or the abnormalities. So there are chances of missing some other kind of abnormalities. So that is basically meant by data set bias, and some hidden subgroups of patients or mislabeled instances. So even though many of the data sets, whatever is publicly available or available in the internet, are having labeled data, but in many...
Rajashree ma'am.
Yes, ma'am.
Madam, the screen it's not changing.
Ma'am, right now I'm in the data, this screen slide on data sets and image format. Is it visible, ma'am?
Yes, ma'am, visible, but I think network slow is.
Okay.
Screen is
Okay.
still there.
Okay. Okay. I'll just check once. Is it changing now?
Yes, yes,
So that can be a problem with the data sets which is available because the mislabeled instances. Because even though we are taking ground truth images from that, if the labeling is not proper, then it can affect basically the training of the model and the output of the algorithms. So these are some of the challenges normally researchers are facing because of the image formats and the data set which is available. Now, coming to the challenges and opportunities. So, as somebody, some scientist and Dr. Paul Chan, he's a professor from University of Chicago School of Medicine. He told that deep learning is not going to replace us, but instead redefine us. So this is a very, very important part. It's one of the basic or important challenge basically all the researchers will be facing. This is like how to convince a doctor saying that, okay, we are not trying to replace you. We are trying to develop a model with which your analysis will be very easier, or it is going to help you in the analysis. So the future of radiology is indeed a very, very hot topic in healthcare. So the role of smart technologies such as deep learning and artificial intelligence play within radiology continues to spark both fear and interest. As I told, there are many people when we go as our part of our studies also, when we approach many hospitals and clinics, the first question they'll ask us, okay, all the researchers from the engineering or the academic fraternity, you people are trying to make or develop algorithms where we are trying to replace a doctor. So this kind of a fear or maybe interest, so we cannot replace a doctor. We want them to validate the data, to annotate the data, to give valuable suggestions. Any research which is happening in the field of medical imaging, it's not complete with the support or the help or the valuable contribution from a doctor. So the reality is that they're both potentially very useful technology that will add value to the field of, in many ways. So this is one graph. We have got it from a latest research paper, which is published in 2022, which basically, even though we talk about data sets and when for the deep learning network, we need thousands of thousands of data. How many ever number of data are more your training model or model will be able to predict it properly. So this is a normal notion, but it's, in one way it's correct. How much ever data, more data, if you train the system for that much features, the model will be able to understand and will be able to predict. But the a paper, a recent paper, which basically does a study. They've done a diagnostics of Alzheimer's. So they have taken, they've reviewed some articles. So the first graph, A graph, shows the publication years of these papers and the number of subjects in the study. So if you observe that the papers are taken from 2017 to 2020, this years, in publication years, we can find an increase in a number of subjects with, who is actually undergone to the study. So as many number of like patients or images we are getting. So your model, whatever we are developing, it will be more accurate. Normally, that is the conception. So that's what actually the first graph says. And the second one, but according to this research paper, what they tell us, larger brain imaging data sets are not enough for better machine learning diagnosis in case of Alzheimer's. So what they have predicted is, even though the number of subjects in the study have increased over a period, but if we actually see the accuracy, the prediction accuracy and the number of subjects in study, we can actually see that the graph is not going that higher. So there can be reasons like because of some data, like the maybe it can be a problem of not properly labeled data or some image formatting of the data sets. So there can be some challenges that can happen in this way. So here, so one of the main challenges what most of the researchers will be facing is with the data image annotation, basically. So in some of the seminar, they'll tell if your input data, whatever is the annotated data, if it is proper, then half of your work or the most of your work is actually done. So then you have to only concentrate about how to develop a model or the training aspects, all that. So there can be the challenges in image automation as well. So colleague Dr.VEENA will be discussing about the challenges in image annotation and what are the different tools which we can use for image annotation. So over to Veena, ma'am.
Yes, ma'am. Thank you. Ma'am, is the screen visible?
Slides not visible.
It's not visible. 1 minute.
It's not visible, ma'am. I'll just try to stop
Yeah,
sharing.
yeah. Yeah, you can stop sharing, ma'am.
Now you can just try, please.
Okay. Good afternoon, everyone. Myself, Dr.VEENA Divya K. I'll be continuing the problem statement with what Rajashree ma'am discussed. So just give me a minute. Is it visible now, ma'am?
No.
Yes.
Now it's visible?
Yes.
Yes,
Slides
ma'am.
put in
Thank
the
you, ma'am.
presentation mode.
Yeah, put it on the presentation mode. Maybe there's a delay. Please excuse me for that, ma'am. Is it visible now, ma'am?
Yes, ma'am, visible.
Okay, thank you. So, with the continuation to what Rajashree ma'am explained, we will be talking about a case study which is relative to how deep learning models will be supporting the image, especially in medical image processing, and how machine learning will be assisting for the medical imaging. I do have a case study here. I am presenting this as one of my research topic, wherein I have faced all the hurdles and different drawbacks which I had to go through, which definitely would be the same for even the brain images as well. So whether it is a 3D sliced image or whether it is a 2D image, apparently I'll be taking a 2D image into the case study for consideration, but the process or the procedure remains the same for developing the models in using the machine learning for medical imaging. So what all were the methodological failures that I did incur at the time of research, and also the recommendations that I would possibly be suggesting would be the part of my talk for the day. So eventually here I'm taking a case study of a digital panoramic radiograph and how I came across different procedures before building a model which was sustainable. Main thing, like Rajashree ma'am mentioned, having a model or coming up with a machine learning application definitely needs to have a validation, which we all faced during our research tenure for getting a doctor's validation done, and as well having taken into account whether the doctor is able to accept the results with a promising note. So one usage here was for a proper planning of a proper treatment plan. The second one was recurrence of the patients who came back to the hospital and trying to have an analysis for the root cause. So here in this, we have taken a common problem trying to address different anomalies that is there with reference to teeth. So I will be starting with the image extraction procedure, what a little bit of information as to how this 2D radiograph does look like. So image extraction procedure for the 2D digital radiograph is the patient will be situated in the center of the unit. Like this is an ultrasound image because it's a X-ray image with a 2D focal spot. So eventually the exposure time remains around 12 to almost 3.2 seconds, 12 seconds to 3.2 seconds with a normal dental arc. So with that, we concentrated mainly on the jawbone cyst or the cyst of the jawbones. So it is basically the cyst that is being defined as a pathological cavity. It is inbuilt within its own capsule. Sometimes it is hurting the patient and sometimes it doesn't hurt, remaining as a solid or a semi-solid content within the epithelium. So that's again relative to tooth decay, which is also referred to as dental caries, again referring to the cavities that is affecting the teeth. So we had a little bit more insight about the research work here. We had a very small number of data set when we started the research. So eventually I had to go ahead for having multiple numbers of the teeth images so that my model would sustain for the application that's being built. So a little bit more information on what happens if it's not about the larger data sets and I'm only trying to address a very smaller data set, like in my case. So if it is about the larger data set, means the availability of labeled data set has always important when we are trying to use machine learning or deep learning models. So when we are trying to gain an access to a larger data set, then it's definitely difficult for us with the machine learning problems. It could be with the computer vision, wherein we have the data sets which contains millions and millions of images, like just now what Rajashree ma'am showed. There also we have a repository for the brain images, the MRI images. So definitely one important thing here to notice that we do have hope that a similar possible progress which might happen in the medical application will have a one repository which will be used as a standard repository over all the different problems within the medical image processing, wherein the researcher might not go ahead and do again a research back with whatever is being done already. So with that on the note, we did come across data augmentation. So a little bit information about what is data augmentation and why this is pretty much required. So eventually data augmentation is improving the medical prediction accuracy. How we will be utilizing the scaling of the data with different sections of increasing the available data into adding more number of data points. So this will again be reducing the cost of the collecting and the labeling of the data. Apparently, apart from that, it will be preventing the data scarcity for the better models. So as we have come across with the machine learning and the deep learning concepts, having more number of data is always told to be giving a positive approach towards the model, as well as the deployment of the model to work fine for the other data once the model is being deployed to check and validate the approach is always depending upon the number of data that is available. So going into that, we do have the application here wherein we need to understand that the increasing of the generalization ability does provide with the reduced cost of collection of data, one thing. Then it will be improving the model prediction accuracy. That's an important point to note, that it will be improving the model prediction accuracy, plus it will be preventing the amount of data that is lesser as compared to the case study that I have taken, because eventually I had a very small data set of ET images, that is the cyst images. So the frames, once we are trying to augment, will be giving better models, plus it will be reducing the data overfitting. So when we are trying to train the model, in case we are coming across overfitting, then definitely augmentation takes care of reducing the data overfitting, and henceforth it will be creating variability and flexibility in data models. Okay, so that is in data augmentation, how the medical images are being improvised with the available limited amount of data, and how we will be able to have approximation towards understanding of either changing the angle, flipping, or trying different sequences. So how do we improvise the vision is very much important in understanding, henceforth to go ahead and have a model performance by reshaping or resampling of the data. So with this note, I have used two important tools. To be one specific, there are two tools which I'm not, let me be very clear, I'm not trying to promote this tool, but eventually this was a very good tool which helped us in annotating the images. Plus it tried and had a very good augmentation also with the the interaction of the doctor at each and every step, wherein the doctor as well as the research scholar both were involved in annotation of the images. And finally we came out with a very good model which was supporting for the doctor saying that he did have, or he did come across a positive result. So Supervisedly is one such platform which is there for the entire computer vision life cycle. That is starting from the image annotation and the data management. they do have the option of having infrastructure relative to holding on to the data with privacy and plus deployment of the model with the training. So these are the major clients who are working with the Supervisedly layout as of now. There are certain requirements which I wanted to stress upon here, because apparently most of us would be using tools like Python and MATLAB, which are readily available, but usage of these tools does require different pre-requirements. So we do need to have a Docker that's been installed with the Linux platform. Then a GPU is always preferable. Plus, we need to have this being utilized either through the AWS, or we can go ahead and utilize our own GPU CUDA, which is there for our laptops. That's again left to having based on the cost effectiveness of the laptop. So apart from that, the GPU instance deployment with the memory. Memory is always a constraint when we are trying to build or train huge data. So it eventually took for us days together, almost like 6 to 7 days, for us to have one batch of data being trained and finally the model being evaluated with necessary fittings. So memory, again, as good as GeForce RTX 2080 or 3020 will also be good when we are trying to build this agent onto our laptops itself, so that we are not trying to pull this up onto the AWS cloud. So moving on, there are certain steps that needs to be performed here for having the data set being built up into the project that's being created. First of all, Supervisedly tool does have an application wherein it is free for us to use for certain limited amount of data set. So apparently after that, we need to purchase the subscription basically for having more number of data. Plus the labeling also does happen with different types of techniques, wherein we do have bounding box, wherein we do have border labels that is basically used for identifying different sections within the medical image or different characteristics of the image that we want to pick up. So eventually, after importing the data set, we do have this annotation layout, which does take the help of the artificial intelligence, depending upon what are the important parameters that we want to highlight here. So as I mentioned, I was working on the cyst, which is present within a 2D image. Like Rajashree ma'am mentioned, we do have the hindrance of the bone and the soft tissues that is being overlapped when we are trying to gain, or we are trying to extract an ultrasound image, especially with a 2D. So 2D image was really difficult for us to identify which exactly is a developing cyst or initial cyst conditions, and wherein we could actually visualize a cyst wherein it was at the mature or the premature stage. So we did take considering both the cases, plus due to the shortage or due to the amount of less number of images, eventually it was really difficult for us to have the annotation of these images with the backend support from the doctor. So once the data annotation is being done, as you can observe here, we did have the statistics also being provided to us, which is very important when we are trying to use this in machine learning and deep learning models, because depending upon the class that we need to identify how many number of images were labeled, how many number of images did get an acceptance from the doctor, plus how many number of images were ready for the model to be trained, did have a statistics that was being provided with the average class per area and the objects also, the number of objects that was being kept for the count. So here I do have a screenshot of the image annotation statistics, which did help me in understanding how many number of image annotation was being done with different classes. So with that, the next stage is configuring the model before training. So this, we do have a support in Supervisedly, wherein we did have different pre-trained models, which will be giving us an insight or helping us to have the model being trained with the data set that we have annotated already. So this, as you can observe here, we did have a percentage being given for training and a percentage being given for validation, that is being separated. And finally, with the conditions, as we can observe here, for the segmentation, I tried first with different set of segmentations, that is being categories that's being available. I have preferably used instant segmentation because that provided me with a very good result as compared to the other types of segmentation methods that were available. So with that, we can have the model being trained with the option of having the annotations being done with the augmentation. So just a recall of what augmentation was. Likewise, I mentioned I did have 80 images which was being given to me from the hospital, but apparently due to the lack of less, because the model itself will not be ready for training if in case we don't have at least a minimal of 200 images for us to go ahead and train. So I did have the option of augmenting the data, then going ahead for annotations, and finally developing the model for training, so that, as you can observe here, I do have 2,850 images that is being done with the annotation, with the total set, the data set of 5,808 images. So once that is being done, the training graph with the other classification, with the other metrics are being observed. The performance metrics are being observed with the results being given on the terminal window. So why I have been very specific about giving all this important information is that when we did try to go ahead and have our machine learning or the deep learning approach, the next content will be deep learning approach. But there were hindrances to understand and finally to have these annotations being done, plus the augmentation of the data, wherein it took a very long time for us to note for the different annotations that were being available, like in a single integrated platform. So here we wanted to share our experience so that anyone eventually working on this particular domain, that's medical image processing, not only being the MRI or the CT images, even 3D models are being supported in DICOM format with the latest version. But eventually it wasn't available when we started with Supervisedly. So coming back to the workflow, once the model is being done, the training is being done, and finally we do have the statistical results. So we did have a comparison wherein the clone part is basically mentioning the augmentation of the data with different other comparisons, as you can observe here, using a faster RCN inception and the model that was being used here to train finally with the marking or labeling of the images with the inference. So we do have a workflow which gives us the entire layout, which we can utilize, or we can have an inspection of where we are actually trying to go wrong, or maybe try with the different other models that are being available. So apart from this, this is how I was able to classify. Once I did have the result that is being tested for validation, I was able to classify following the result being cyst with the category or the class that I have already shown in the previous slide. So this classification did give us a very good result, which did again give a feedback to us when we tried presenting this work with different conferences, like in prior we did have a conference in EMBC, then we did have a conference in EMBC Jeju and EMBC again in Japan. So wherein the doctor did present this work and he really got a very good appreciation as to how the results are being given with a promising output. So with that, we did have a model being built, the application being built for RV Dental College. So this is where I had a collaboration with, like Rajashree ma'am mentioned, we did have a hindrance before actually obtaining the ethical clearance, but once we got the ethical clearance, we did have more set of data that was being given to us to work accordingly, and finally we did come up with even mapping different teeth within the digital radiograph. Again, that's one of the next work that we took it up. So that's again using the bounding box technique. As you can observe here, we did have the identification or the recognition of the different teeth structures, basically to have a treatment plan. So eventually when the patient does come, what will be the number of teeth and how many are with or without different categories was being mapped here, and we did do the work using Supervisedly here as well, wherein we did have the bounding box annotation that was being utilized. So this is one such important part of our research, wherein we came up with this case study using Supervisedly. So this structure with main important aspect being the time. So the doctor, once validating the result, did give us an let's say an appreciation relative to the time that is being taken for the identification, though still we do have a long way to go ahead for identifying other different anomalies that is being present within this 2D, but still we are now trying to move on with the 3D, that's the CBCT images that is being utilized, like our brain MRI images on the other side, wherein we could annotate and have the slices for being trained with reference to identifying the different anomalies that is being present. Again, that's a different problem statement all over again. So this is with the 2D radiographs what we have tried to achieve. And the next one which I wanted to discuss is again, let's be more advanced of what Supervisedly is. So here in V7, this is what we are trying to use right now. So after understanding the drawbacks of Supervisedly, V7 again is an image annotation tool that's being provided with a company which is based in UK. So here also we do have a very good platform, an IDE that's being created from the annotation to the deployment. Plus one advantage here is we can go ahead and build our own applications like the apps once we have the model being trained and deploy it on a standalone device. So again, here as well, the doctor's consent is also being taken into consideration, and we can have a team of annotators here, not just one, wherein as considered in the Supervisedly, but in V7, we do have an option of having more number of annotators who can work together, because if it's more, let's say 1,000 or 2,000 number of images which is being present, we do have an option of having different set of annotators who will be working on different classes. So ultimately that can be integrated and the training can be done, which is pretty much almost 10 times much faster, because as I mentioned in the case of Supervisedly when I've used, so we've almost taken for the batch processing itself to run for the entire day and night almost 6 to 7 days for a particular class. So but with V7, this won't be the possibility, but instead it will be taking 1 or 2 days as compared to Supervisedly. So this feature mainly helps us to have object detection. We do have semantic segmentation, we do have instance segmentation, volumetric segmentation, and composite objects. The main advantage here is, as you're able to see in this GUI, so it will be trying to understand the importance based on the AI agent that is being, machine learning agent that is being deployed at the time when we are trying to annotate. So as I have visited many number of machine learning and deep learning workshops, wherein always we have got information from the relevant speakers that 95% of our job is to have the proper data set which is being labeled. So apparently it's just the next 5% of the concept does come into picture, wherein we do have the training and deployment and finally having the performance of the model that is being obtained. So it is apparently the most important part is to have the labeling of the data. So likewise, I portrayed in having used Supervisedly, wherein I did have the bounding box. So bounding boxes especially is a cause of hindrance, wherein I am not able to highlight the boundaries as it is being done in this case, wherein it is trying to highlight the bone of the image, right? So one more important thing is, once the image characteristic is been understood, it will be able to work, or it will be able to highlight the other objects that is being present within the image just with a scroll of a button. So we need to have a class that's being identified and a tag. So as you can visualize here, once it is being highlighted, then definitely it is giving the class automatically and the tag is being created. So entirely this is neural network based, and there is no statistical hackery that's being involved. Again, very important, developing FDA and EMA compliant medical applications, which is again within the standard compliant environment, which will be including clinicians also as part of the team. So that's a main advantage here which we came across, and right now we are using this. So the differences between the V7 Darwin and the Supervisedly. So automated annotation is being possible. Then we have a client level information that is being thrown up directly into the AWS cloud, and we can have the support wherein I told you, instead of using memory or the GPU that is being available as a standalone, we can even use the AWS cloud if we are having more number of images, so that our model is much more on the positive note. So apart from that, we do have a support that's being given for DICOM, high resolution, and the model training is also present here. But eventually in V7, Supervisedly also, we do have model training that's with a very limited number of images that I showed to you. So how do we label and how does it work? Like how to label MRI and the CT image? I just have a video to show for the demonstration. Just give me a minute.
Hello, madam.
Just a minute, ma'am. I'm just trying to play a video.
Yes.
Ma'am, is it audible?
Audible, ma'am. Video.
The video, is it audible? Rajashree ma'am, can you please
No,
share the
ma'am.
video? Ma'am, can you please share the video? Because I think there's a problem with my laptop. Ma'am, are you sharing it?
One second, ma'am. Just
Yeah, thank you.
Are a form of planar slice data, meaning that ultimately they're a series of slices. And if we want AI to learn to identify
is it audible now, ma'am?
Yes, ma'am, it is audible. Thank you.
objects within them, we need to embed these objects within each slice. I'll be demonstrating how to do this on V7 Darwin. We'll be covering image segmentation of an MRI and a CT scan. Let's start by creating a dataset. We'll give it a name, and we can upload some data. We can do so via the browser or using the CLI by first installing Darwin Pi, then Darwin Dataset Push, the name of the dataset that we created, and the path of the files that we want to upload. You can also just create the dataset with Darwin Pi. And you'll find all these commands and shortcuts on pypi.org/project/darwin-pi. When our data is uploaded, let's create some classes. In this case, I'll create a hard class. I'll give it a polygon mask annotation type, and then we can give it some subtypes. These can be directional vectors to show where they're pointing, attributes to add more detail, instance IDs, or text. We'll be adding instance IDs since this is a 3D segmentation project. Within this new dataset, we'll be looking at 3 cases, and to browse them, we can use the filtering options on the right. If we head over to the Classes tab, we can see all the classes that we've created, as well as a little overview of all the annotation types we have available. And finally, in the Overview tab, we'll see an overview of the dataset's progress in the various classes to see how frequent they are within the dataset. Let's head back to the data and head over to our first case. Like most image annotation or DICOM viewer, Darwin allows you to manually label things within images by making, for example, a polygon mask. However, as an AI platform, it also allows you to leverage AI to make these annotations autonomously. Use the auto-annotate, or N, as a shortcut to create segmentation masks automatically. Darwin tries to understand the objects you're encapsulating, such as this white matter lesion, and paints its pixels. You can click on a new area to include it, and as you'll notice, the accuracy of it is at a pixel level. You can also add comments on the images to discuss cases with your colleagues, or annotations if you're part of an annotation workforce. And here's another tip. You can change the image manipulation to reduce the opacity of the annotations and see them better in faint medical imaging. We'll continue the annotation of these white matter lesions and watch as Darwin adapts to understand them. We'll click outside the polygon to include a new area and inside the polygon to exclude it with these red markers. You can also click on the markers to remove them. All of this is done through a deep neural network designed to learn and adapt to any object, either in the medical or non-medical world. Now let's look at our final result. This full segmentation took a couple of minutes to complete. Let's look at case number 2 now. We simply have to segment the kidneys of this healthy patient. We'll create a couple of auto annotations exclude any unnecessary marks, and then we'll reveal these sub-annotations. This will show the instance ID of these kidneys. It's a unique number and color combination to indicate that this is kidney number 1 and the other is kidney number 2. We can track these numbers throughout the various slices to show that it's exactly the same organ. This does not make a lot of sense in kidneys, but if you think of blood vessels, you get the point. Moving on to the next slice, we can use the Copy Instances button to copy over the previous annotations. Things have changed a little bit, so we can click on this button to edit the auto-annotate output and adjust its box. Darwin will adapt to it automatically. The shortcut for this is M. We'll do the same on the other kidney and clear these points to make sure we don't exclude anything. Move on to the next slice and repeat the same thing, making sure that we're still looking at kidney number 1 and kidney number 2. And here's our final result, which also only took us a few minutes. Now for our last case, we're going to segment this aorta, and while doing so, we'll add an attribute to it, the fact that it is normal. Attributes are like tags that are applied to annotations to give them more information. You've seen this before, so we'll move quickly. Each slice is taken between 10 and 20 seconds to complete, and little by little, we're creating a volumetric map of this aorta. As it starts to grow, auto-annotate adapts to it and reforms its shape, until ultimately it starts to become evident that something is wrong. We'll edit the attributes for this, remove the normal attribute, and add an aneurysm one. We'll continue to track the aneurysm by copying over the annotation with this attribute appended to it, and let auto-annotate adapt to the new slice shape. After about 5 minutes, we have a complete segmentation of the aorta in 3D slices. Let's look at the results. Now this is only one part of the body, but auto-annotate can adapt to any organ. This type of segmentation ultimately allows you to create 3D representations of the human body or identifying anomalies with AI. To try this out, head over to v7labs.com/Darwin or check out more tutorials at v7labs.com/academy.
Thank you, ma'am. So that's how we can actually annotate and finally build a class and get into the option of training the model and have the model being used for analyzing the data that we have used. So apparently, as we saw in the video, it took approximately some 2 to 3 minutes to identify, including the regions that was being marked as an important characteristics with reference to the different slices of the image. So with that, we would like to end this session. This is the references that we have tried to use. We hope we have given information related to how we can actually go ahead and try to have a very good machine learning being built, model being built for medical imaging. Especially, we have tried to address the methodological failures, and like I mentioned, the recommendation for the future will be usage of these type of applications wherein we come across having an integrated environment for having the models being built, trained, and finally validated by a set of doctors, plus having a standard set of database of the images representing a repository, which can be again integrated with all the team of researchers who are working across the globe, having an insight into coming up with addressing more number of anomalies rather than just going ahead and finding faults in the other different type of smaller data sets that's eventually not contributing to the team of research. So with that, we end our session here. We thank Dr. Usha Desai ma'am for providing us an opportunity. We thank SRM University for giving us an opportunity here to share our thoughts with what exactly is the required topic, or let's say the future of medical imaging with the machine learning and the deep learning perspective. So thank you so much, ma'am. Rajashree ma'am, are you?
Dr. Divya and Rajashree.
Yeah.
Ma'am,
Actually, you are in
any
now
questions?
holidays now.
Yeah,
In
I'm
France.
actually in Germany. Yes, ma'am. I am in Germany right now, so it's a family trip. I've come to meet my husband. I'll be back by next week. Thank you so much. It's
Thank
an
you,
early
ma'am.
morning here. Yeah.
Audience have enjoyed your sessions. And there was one of the question, I think, from
Yeah. Any questions? We are happy to answer.
Madam Megashri is here. Participants, if you have any queries, you can discuss with Madam.
Yes, ma'am. We do have our contact address also here. Just be sharing that.
Hello.
Yes, sir.
Hello, madam. Excuse me. Hello.
Yes. Yes, sir. Good afternoon.
Good afternoon, madam. Small doubt, madam. This type generally we are different image sets. How we can download, madam? Different types of medical image data sets. Is there any authorization is required, madam? Otherwise, directly next flow.
Usually, you can download with the repository that we mentioned here. We gave an example for MRI images. So apart from that, also there is a website known as Kaggle, Kaggle, Kaggle.com, wherein you have different repositories of the data that is being available specifically for medical images.
Okay.
You can download them. Yeah. Or when you're trying
sir,
to refer to yes, ma'am. Yes, ma'am.
Yeah, so when you download and use the particular data set, sir, once you get a results or published paper or something, actually we have to, in the reference, we have to mention, because we have used this kind of data sets, all that. So in reference, actually when you go to the websites itself, they'll tell what are the citation we have to mention.
Okay.
Yeah.
Okay, thank you.
And some data sets are publicly available. Some on a request basis, we have to like contact the authors or
sharing the data.
Yeah.
Okay. Another doubt, madam. Before actual medical image processing, generally first to post processing stages or pre-processing stages by using different types of filters. So what about the accuracy depends upon the by using these filters, madam? Maybe in concept of generalized time domain filters, decomposition based filters are there. A lot of filters are there. So what about the accuracy related to that?
So that's what, before we train, we need to have, let's say, one or two methods of pre-processing, wherein you try to, have the entire data set onto one perspective. So based on that only, we'll be trying to train the models.
Okay. So suppose we change the pre-processing stages or post-processing stages. So whatever may be the data set we are using, the results also changes. So by using that,
so that's what we actually meant in having a standard repository, wherein all these images will be taken from, either they are being taken from a different source, because taking from a different source will definitely have an impact on the data set. So that's why I gave an input here when I was presenting with my test case or the used case. So depending upon the source and the amount of voltage and the current that is being utilized by the source to produce the ultrasound or the X-ray, the image variation will be there. So ultimately, even though we are trying to extract that in DICOM form, wherein it's at the crude stage or the initial stage, but still that the entire set of data that we are using to train the model and validation will be only satisfied for my entire data set from that single source or from that single machinery that we have used for analysis. So this is what we actually meant when we are trying to have a standard repository wherein all these pre-processing conditions are being taken care before itself, and then we have this repository being put up onto a website wherein each of the researcher who is trying to work on it will be mainly focusing on the anomalies and not again going back and having technical issues in understanding what exactly is the lacuna with the model being trained, or let's say the entire data set being taken from that particular repository.
Thank you, ma'am.
You're welcome, sir.
Hello. Good afternoon, ma'am.
Good afternoon, ma'am.
Good afternoon.
Ma'am, I would like to know about annotation tool what you have showed us. So whether this tool is available publicly?
Yes, ma'am, it is available publicly.
Can you please share the link of that?
Yes, I'll just share it to you. So this
And
is
one more thing I have a basic doubt is we have a repository where we can get the data set and working with that and also collecting a data, medical data from hospital. So how it this difference matter?
definitely there will be a difference, ma'am, because likewise I mentioned there is always a conflict of understanding wherein we do have the source which is pretty much different. Likewise, sir asked the question. So there will be a difference when we are trying to obtain the images from a hospital to a standard database as always. Rajashree ma'am, can you elaborate because ma'am has worked on that? Rajashree ma'am?
Yes, ma'am. So the basic problem is, ma'am, when we mention about the data set and the image format, all that. So basically, my research work is in the field of breast cancer imaging. So whereas when we see there are many publicly available data sets available. So in the database, for one example, there is a example called as NIAS database, where the image format is a different version, and we have like something called as uh, another database where the images are in the form of or saved in the form of JPEG. But the problem is when we go to a hospital and collect the images, actually in all the images or the medical institution, normally the images will be saved in the form of DICOM. So once you try to convert the DICOM into a JPEG or any other format, there are chances of the data loss and all these problems. So that's the basic disadvantage. And as ma'am mentioned, the sources or the equipments that they are using to collect the images, that is also different. So because of that reasons, the images whatever normally when we'll get from a like internet or the publicly available data sets and the hospital, there are a huge difference. So when you train a model with the like a publicly available data set, and when you try to test us on test us on a data set which we are getting from a hospital, sometimes our model may not give that much accuracy. So there can be some problems. So in my case, I faced that. So because of the image formats and the labeling, all these because of the problems.
Ma'am, if you are directly working or training the model using hospital data set, then it of course no getting a data from hospital, they have their own ethical issues.
Correct.
And getting lots of data from hospital is also it's too difficult.
Problem. Correct.
And
so the same thing, ma'am. So in the case of like getting hospital, the first main problem, whatever the challenge we'll face it like getting an ethical clearance, because we are working on medical images or medical data. It's a very secured kind of data, and we are working directly. And many patients, sometimes if you're working on real-time data, if you're collecting, we have to get the consent from the patients itself. Or if you're working on images, sometimes they will share the images, but hiding all the information, like the patient details, all the demography, all the informations will be hidden. Then only they'll share. But there will be for a doctor to sit and annotate and give you the data. It's a very a huge task, because there won't be enough time for them to annotate and give you all the informations. So that's what, in that case, this kind of annotation tools can be helpful. But here also, even though you're using annotation tools, you need to include the doctor and get a validation from the doctor saying that the annotations are correct. Because in V7, basically in the tool, we have options to include doctors or other team members, where they can actually validate whatever annotations you have done, that they can, there is an option to validate. So that's a main challenge. Exactly.
Means like importance or more weightage has to be given for the one who works directly on a hospital data set, right?
Mainly most of the paper, when you try to publish your work in a reputed journal or conference, in most of the journals they'll ask the ethical clearance report from a hospital and the doctor's validation. That's a must. In many conferences or journals, if you're working on a medical related topic, they'll definitely ask you for the ethical clearance report or the data. So if you can provide, if you have a collaboration or ethical clearance of the data, that will be very useful, or it's good.
Okay, ma'am. Thank you. Please share the link for annotation tool.
Yeah, thank you. I will share that. Ma'am, Meena, ma'am?
Yes, ma'am.
We'll put it. Ma'am, we'll share the link
Yeah.
in the chat box.
Yes, I'm sharing it, ma'am.
Dear participants, we'll have a lunch break now, and next session will be in the afternoon. Actually, which was scheduled session by Professor Shabarimalai Madikandam. It will be held tomorrow. And today afternoon we have experimental paradigm in BCI by Dr. Ravichandra. That will be in the afternoon from 2:15 onwards.
Ma'am, I've shared the information on the chat box.